Hello, and welcome to my Pre-Algebra review series. This video covers Chapter 6, Section 10, titled Make a Table. We start this review with the reason to make a table. We jump straight to a real-world problem that is handled over many steps, creating a table to solve a problem. This example uses the familiar read and understand, plan and solve, and look back and check system of discovery we have seen before in previous chapters and sections of your book, your textbook, and this review series. Please leave a like if you find this video to be helpful, and give your classmates a heads up too. It will more than likely help them, and certainly it will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. So let's get into it. Objective 1, make a table. Have you ever watched a baseball game at the field that does not have a scoreboard? It's hard to keep track of the score. You know, the runs, hits, the errors, when they happened, what inning they happened in. It's all pretty complicated. You can't remember it. A scoreboard is like a table, however. You can use tables to organize information. Tables are particularly helpful in solving problems that require several steps. So these tables help organize the data and that you can know where to look and how to find the answers you're looking for quickly, as in the scoreboard we were talking about here. Example 1, and we have an A, so it means there's going to be multiple slides, all called Example 1. Example 1A, a real-world problem. Population growth. At the beginning of the year 2000, the population of the United States was about 273.5 million people. The rate of population growth was about 0.85% per year. If that rate continues, what will the population be at the beginning of the year 2010? Okay, so the growth is 85% per year. We started at 273.5 million. What will it be in 2010? So then they come up with we have this read and understand segment we're in now. It says read the problem carefully. What information are you asked to find? Well, if we look through it, it says if the rate continues, here we are right here. If the rate continues, what will the population be at the beginning of 2010? That's the question right there. So the answer here is going to be population at beginning of 2010. Oops, 2010. That's what we're looking for. What information will you need to use to solve this problem? Well, to start off, you're going to need the population in the year 2000, population in year 2000, okay, and we're going to need, we need the population in 2000, and we need the growth and the percentage per year for the growth. Okay? Okay, that's what we'll need on that. So now read and understand. That's the second phase of this process. Decide on a strategy. How do we think we're going to resolve this question? You can use the percent of increase to predict the population increase for each year from 2000 to 2010. They've only given us one percentage. You can make a table to organize your predictions for each year. How can you find the increase in population from the beginning of 2000 to the end of 2000? So you can do that by multiplying 2.73.5 million people times 0.85%, and that is going to give you the percent that's going to increase. based on this original number, and then you're going to add the original number, the 2.735 million. And so the 273 million plus 0.85% of 273.5 million, we're going to end up with a larger number, larger by 0.85% larger in terms of 273 million. So that's how you're going to do it. You're going to multiply those two numbers, and you're going to add the beginning number. And that number is then the beginning of the next year. So how can you find the population in 2001? At the beginning 2001, you're going to take the population increase, so the pop increase, pop INC, plus the population, and add them together, and you're going to get the new population, or the 2001 population at the beginning of the year. At beginning. At the beginning. Okay? So the percent of increase is the same each year. Does that mean that the population increase will be the same for each year? Well, no, it cannot be. The population is going to increase every year. It's going to increase a little more because the percentage remains the same, but it's going to increase because the base population is increasing all along. So every year, the population increase will be a little bit larger than it was the previous year. Okay? Population will increase. The percentage amount each year for each year. Okay? Okay, example 1C, for that same real world problem, we're going to copy and complete the table. Well, you don't have to do that because the numbers are already there. If you look at the red numbers, the table's been completed for you. We're just going to go over it, and you don't have to do the mathematics or the arithmetic on this. It says, find the numbers. So here's what we're going to do to solve these answers, the answers in red down below. First, we're going to look at the beginning of the table to understand how the table works. So the table says, first, find the numbers for column 4. So we're going to find all the numbers for column 4, which change as you look down here. You see they change. Find the numbers for column 4 by multiplying the numbers in column 2, that's back here, column 2, and column 3. Multiply 2 and 3, round to the nearest 1/10 of a million. So let's go right there. If we take what they're telling us is we can find the value of, I'm going to put this in red, that the value in right here in column 4, 2.3 million, is created from multiplying 273.5 million by 0.0085. And when you multiply 273.5 million by 0.0085, you're going to end up with 2.3 million people. Okay, that's all this number 6 is telling us to do. They showed us how the numbers are created. And we're going to need that because we're going to have to create the next step. And through the table, you create one step, then the next step, and then the next step, the next step, the next step. You just go down the line until you get the table filled in. So then, once you've done that, and you've rounded, and you've entered the value here in table 4, then it says find the numbers for column 5. Well, column 5 are what? The population at the end of the year. Well, how did we get the population at the end of the year? We got the population at the end of the year by taking the population from the start of the year, adding the increase during that year, right here in column 4, which is the increase. So you take 2, and you add 4, and you end up with 5. And if you look at it, you get 273.5 plus 2.3 is 275.8. They just add them together. Okay, and that's what this says. It says find the numbers in column 5, hence the column 2 next entry. You see that? So once you find this number here, 2.75, 275.8, excuse me, you carry that down to column 2, to the next line in column 2. Here's 275.8. So the line here, the first line, 2000, year 2000's population at the end of the year is the year 2001's population at the beginning of the year, and that's what column 2 is. So then we've got that, and then it says here by adding the numbers in columns 2 and 4, and that's what we did. We added 2 to 4. We ended up with 5. We took 5 and moved it over here to 2 of the next year. And it says sometimes the numbers in column 4 change from one year to the next. Explain. Well, why is that? And I kind of alluded to it, I think, when we started talking about this, but maybe I didn't. The numbers, we're dealing with 273.5 million people, and that's up 0.0085%, or 0.0085 decimal, and you get 2.3. Well, you multiply by that 0.0085 again on a number that's almost the same size, and you can get 2.3. But eventually, this number here in column 2 is getting larger, and each year it gets a little bit larger, a little bit larger, a little bit larger, and every time you multiply by 0.0085, that number there can maybe get larger. So you see here in 2002, it's now 2.4. And in 2003, it's 2.4. 2004, it's 2.4. 2005 is 2.4. 2006, however, it is still 2.4. In 2007, guess what? It's the first number they want from us. It's going to be 2.5. That means eventually this number here in column 2 got large enough that when you multiplied it by 0.0085, we've now jumped 1/10 of a million people of the increase, and they want to round to 1/10. That's why it took a little bit longer for this to increase. So how do we find out? We take, again, going back, now it says, we've explained forces. What is your prediction for the population at the beginning of year 2010? Well, here's 2010 way down here. They want to know what it is at the beginning of the year. How did we get the 297.6? Well, we took what it was at the beginning as we got down the table, what it was at the beginning of 2007, which was 290.1. We multiplied it by 0.0085 right here, and we got 2.5 million people right here in column 4. We added 290.1 to, we added 2.5 to 290.1 and got 292.6. You can't see the 6, but that's what it says. 292.6. We brought the 292.6 over to column 2. 292.6 times 0.0085 gives us 2.5 again. So if you take 292.6 and add 2.5, you get 295.1. You see this, how it's going? And now you move that one, as I said, to the beginning, because the end of 2008 is the beginning of 2009. So we just put the number 295.1 in 2009, multiply that by 0.0085. We end up with the number of 2.5 again. Add to 295.1, we add 2.5, and we get 297.6. And then lo and behold, that's the value for 2009 at the end of the year, and the beginning of the year is 297.6. And that is the answer to this test here, if you will. It's 297.6. Okay? That was pretty easy, wasn't it? And that means 297.6 million people, by the way. Okay, example 1D of this real world problem. We're still in the look back and check. We're another question in the look back and check section here. So it says, your friend says that she knows a quicker way to find the answer. For this problem, she says simply multiply 273.5 by 0.0085 10 times to find the increase for the 10-year period. from 2000 to 2010. Do you agree with your friend's approach? And explain. Well, why don't you go ahead and think about this for a while before I go on? That would be like a check your understanding here, right? Check your understanding for the real world problem. Okay, so hopefully you've stopped the video, thought about it for a while, and now you're back and we have some answer. I'm going to say that the answer here should be, do you agree with your friend's approach? And I'm going to say, no, I do not. And then the question would be, why don't I agree? Well, she's only taken into account the 273.5 million times 0.0085 for the first year. Every year that number gets larger. She just says take 273.5 times 0.0085 and multiply it times 10. That increase will not match the exact answer because it will be too small. It'll be too small because you have to have a little bit larger number each time to be multiplying by the 0.0085. It might be close, but depending on what the percentage increase is, it could be wildly wrong. But I'm going to say no, it's too small. The percentage increase should be higher than what it will be higher than what she forecasts. Okay, example 1, check your understanding. It's your turn. Suppose the annual percent of increase in the population is 0.9%. At what rate will the population, at that rate, what will the population be at the beginning of 2010? So off you go. Draw up a table. It's 5 columns, about 10, 11 lines, 12 lines long. Fill in the numbers. You got to go through all the numbers. Start off at 273.5 and multiply this time by a new number. What's the new number? I'll highlight it here, but you're gonna know it's the new number. But remember, this is a percentage. You've got to convert this to a decimal. And you're going to start off in 2000, and you're going to find out what is the population at the beginning of 2010, just like we did in the previous slide. Okay? Give it a run. I'll wait for you. Okay, here we are. Example 1, we're back. I'm sure you've created a table. It might look something like mine, maybe not. But while we were gone, I created this table for us to look at. And this is the table of the problem. So now we have the decimal place. The decimal percentage for 9.9% is 0.009 decimal. The increase started off at about 2.5 from 273.5 million times 0.009. The ending first year is 276, and then we carried that 276 here over here to the over here to this start year of 2001, and we repeated that over and over and over each time, and eventually down here in 2004 we jumped from 2.5 million to 2.6 million people, and we're at 286.1 million. We get down here to 2009, all the way to 2009, and we came in with 296.6 million, multiplied it times our 0.009 decimal, and we ended up with an increase of 2.7. And when you add that in, you get 2.99 or 299.2 million, and you carry that to the beginning of 2010, and there's our answer, 299.2 million, and that's your answer. You could give an approximate answer. You could say that it's approximately equal to 299 million. Okay, I'll write that in red. That yellow doesn't work very good. I'm going to erase it. I don't even like that yellow or orange. In this case, I think red would work better. And it's going to be approximately equal to 299 million people. Okay? If you got that number or anywhere even near it, You probably did a right job. Might have just made a small error in calculations. Good for you. Take care.